Hello everyone, I'm Dr. Hira Khalid, and today we are going to discuss about enzymes. So in this lecture, we will talk about enzymes. We'll define what the enzymes are, how they work, and what are the different classes of enzyme and on what basis they have classified under these classification. So firstly, let's start to define enzymes. So enzymes are protein catalysts that increase the velocity of a chemical reaction and are not consumed during the reaction they catalyze. So, from definition, this is quite obvious, and you can get the idea that enzymes are protein in nature. So, it means they are made up of different amino acids and they are sensitive to the pH, they are sensitive to temperature, they are sensitive to different different mechanical forces as well. And these are the catalysts. So, what the chemistry point of view we know about the catalyst? So, catalyst is the molecules, the compounds, or they could be the metals, which are basically speeding up the reaction, which create the ease of the reaction to conduct in the less time with the more productivity, with the more yield and the less time and high speed. So that increases the velocity of a chemical reaction, means the rate of reaction is enhanced by using the catalyst and are not consumed during the reaction, they catalyze. It means that they are unconsumed in a way that they are just working as a moderator, as a third party to facilitate the reaction for the smarter and the speedy way. But this is not consumed, this is not the part of the product, or they are not destroyed at a reaction. So you can say, so the proteins, and they could be the whole as a protein structure. They could work in with the metals, and they are called as the cofactors and the coenzymes, which are participating with these enzymes to speed up the reaction. So next slide is that I've used a term that the enzymes are creating the ease of the for the substrate to convert into the product. So there's ease is technically the activation energy. So enzymes are basically responsible for lowering the activation energy. So it means that if you just look at an example, that there is that this straight solid red line is basically the reaction which is uncatalyzed, in which we are not using the catalyst. So it means either we are providing it a very high temperature, either we need to use the very strong reagent for conducting that reaction from A to B, or maybe the S is a substrate and we have to convert into the product one. But what is the benefit? What is the advantages? What are the advantages of the enzymes? Is this one that it is lowering this gap of energy. So this is basically the energy activation energy, means the energy required to modify the substrate into the intermediate or transition state, which can easily convert into the product one. So a substrate, if it requires more energy to get into the transition state. So it means that reaction is slower and we may don't have that much product yield, and we have to speed up the reaction with other conventional methods. Either we are providing, have to use the very high temperature, maybe that, or obviously for the high temperature we have to go for the specialized equipment. So this is not the um, basically is not a cost effective one. So enzymes or the catalysts are basically doing this, that they are lowering that gap And now the substrate are modified from initially to a transition state that which easily can convert into product one. So there is a no more high gap to reach to that activation energy. So that's why that reaction is faster one. So you can see an example that when we are cooking in an open vessel and when we are cooking and pressure cooker, so what we are providing that pressure, which we are in a closed vessel, this is working as a catalyst because now the atmospheric pressure and their vapor pressure is reaching or they are matching at the lower temperature. So that means they are we are heating cooking it and in a more in a less time as compared to the open vessel. And another example, life example, is this one. We have set up some of your major or the bigger goal. So they are the small goal steps or the small tasks which you have to achieve step by step to get into that destination. So these smaller steps has the shorter difference, shorter gap from one step to the second step. And if you're just thinking about from first to the 10th step, so this is the higher gap of energy, and you have to put a lot of things, and you can't achieve unless you are taking the small steps. So the catalysts are basically lowering the activation energy of the reaction. They make they work on a substrate, they prepare the substrate in a way that now the substrate are able to get that transition state with the less energy and with the more speed, so that can easily convert into the product one. So the enzymes basically what it do is that they speed up the reaction rate, sometimes by a million fold. They lower energy barrier for reaction, so temporarily stabilize interaction between substrates, forms transition state complexes, and helps form products. So they are not consuming in that during that reaction. So now in your school, in your high school, in your A levels, or in your intermediate, you may have heard about the lock and key model of the enzymes. So it was proposed by Emil Fischer in 1894. So according to him, that was that there is a specialized conformation, means there is a special shape of that enzyme, active site, and the substrates are rigid. So if the substrate is of proper that shape which can fit into active sites, so even only then there will be the link on binding of the or attachment of the substrate on that enzyme, and then that enzyme activity will be conducted. But then there was the more refined and the more updated form of that model is the induced fit. According to that is the Daniel Koshland 1959 binding of substrates changes conformation of substrates and enzymes. So it means that either if there is a substrate and an enzyme and they are approaching each other's active site, so if there is something that they are not fitting very well to each other, so there are some of the conformation states. So either substrate or enzyme do modify itself in a way that it directs its that best position towards that substrate which can fit and bind to that active site. So then there will be the enzyme and substrate complex, and that is a transition state, and then enzyme activity will be conducted, and eventually you will get that product out of it. To explain this in an equation form, I would like to use a board, and we can see that what I wanted to state here is if we just go for lock and key model, right? So this is the lock and key, and in equation form I will say, okay, I don't use the A, so I will use E for enzyme plus S, and there is E plus product. Now, the induced fit induced fit model is basically is E plus S. S is for the substrate. Then there is enzyme and substrate complex. Then there will be the transition state of enzyme and product, because now the enzyme has conducted the activity on a substrate and it has converted into the product. And after that, enzyme will leave that product to the system once it has completely formed. So in that way, that there are the transitions, they are modifying each other. The substrate is spreading best to the enzyme. Enzyme is conducting its activity on the product, and then eventually that will be released as a product. And this is induced fit model. So now going back to our slides, we'll go for. So next is the classes of enzymes. So there are a number of reactions which are happening in our living system. And from this one thing which you have to keep in your mind, that when we are talking about the biological system, when we are talking about the human cells, or when we're talking about any in vivo system or the living system, so they are the very delicate molecules. So these are basically the lipids, these are basically the proteins, enzymes, and so obviously are all organs and their hormones, the secretions, they are made up of the protein, and our enzymes are protein. So they have to work at a very certain pH level. Let's, for example, if we are talking about the humans, so our we are the warm-blooded and we have the temperature around 37 degrees C, and there is the optimal physical pH for certain activities. So enzymes are very sensitive to the pH, they are very sensitive to the temperature. So this is not a case like the laboratory experiments, and where we can heat up the reaction, where we can use the very strong agents to convert A product into the B product, A substrate into the B product. So there are the enzymes, and the beauty of nature is this one, that we have a number of different biological cycles, and constantly there is a catalysis, there is the where we are breaking down the complex molecules into the simpler one, and there is a formation of um, different compounds as per the requirement of our biological system. So proteins are degraded, carbohydrates are degraded, and of course to the gluconeogenesis and the glycolysis, these are Krebs cycles, there are the citric acid cycles, citric cycles. So these are the different cycles which are uh, maintaining or balancing our biological systems, our secretions, and the byproducts, and they are constantly generating the molecules which are required for our transmission system, for our brain system, for our digestive system, for the water transport. So for our digestive system. So these are regularized, and they all are conducting through the enzyme activity, because now we are not providing any chemical, like we are pouring something, okay, that this reaction has. So this is all controlled automatically. This is well managed system, and they are the enzymes which are taking care of these transformations from the one product to another one. So if we classified these kind of reactions, so they are mainly basically, there are the major 6 kind of reactions which are happening biologically. So more or less all these reactions are related to certain kind of chemical phenomena. So on the basis of that one, enzymes are classified into the 6 main classes, and the enzymes which are belong or which are catalyzing or conducting that kind of chemical reaction, so they have grouped under certain class of the enzyme. So when we are writing the name of the enzyme class, that all ends as ASES, ASES. And when we are mentioning any of the enzyme, so do remember that end at ASE, like urease, oxidoreductase, lipase, right? And if we have to mention the classes, so that will be ending as the easiest one. So now strictly going towards to see what are the different classes and to look into a general kind of reaction and what kind of reaction they are catalyzing. So first one is the oxidoreductases, and these are the enzymes which are involved in oxidation and reduction. And you know, oxidation and reduction involve the removal and addition of hydrogen and oxygen or electron pair. So all kind of these kind of reactions, in a reaction where there is the involvement of the electron pair removal or acceptance. So obviously when there is an oxidant, there is a reducing agent as well. So these enzymes are the oxidoreductases class of enzyme. Second is the transferases. Transfer, and these are the enzymes which are responsible to transfer functional groups, and the most commonly the amino group or the phosphate group from the one molecule, and they are converting it and they are transferring it, either detaching or either they are attaching to the new molecule as a product. So that is the transferases. The third one is the hydrolases, and from the name you can see that it involves the water. So basically, they transfer water, that is, they catalyze the hydrolysis of a substrate. So by involving the water molecule, they are converting the substrate into a particular product. Lyases is the fourth one, and that adds or removes the elements of water, ammonia or carbon dioxide to or from a double bond. So this is somehow the uh, related to the oxidoreductases kind of, but oxidoreductase is fixed to the hydrogen, oxygen, and electron pair, which is traditionally involved with oxidation and reduction reactions, and other than all which involve any kind of reactions where there is a carbon dioxide, ammonia, carbon bonds, double bonds. So these are the lyases. There is the formation of the new bonds or the breaking of the existing bonds. Fifth one is the isomerases that catalyze the rearrangement of atoms within a molecule. It means in a starting, if there was one isomeric form of a molecule, and after the catalysis or the that enzyme that enzyme activity, that has converted into another isomer. So that enzyme activity will be catalyzed by the isomerase enzyme, and the class is called isomerases. The last one is the ligases, which joins two molecules. So there is a formation of two molecules, and with the involvement of ATP1, so they are the ligases enzymes. They belong from that family. Now, next to this tabular form, here, this is a good sheet for you where you can see equation form, and that will be easier for you to remember that what kind of formation it is, chemical reactions they are catalyzing. So if you just look at the equation of the oxidoreductases, so you can see this is the A is a reducing agent and B is oxidizing agent, and there is the oxidation and reduction, right? So here these are the certain examples. Here these are the certain examples of these one. So you can see this is the oxidases, dehydrogenases, oxygenases, peroxidases. So these are the subclasses of these oxidoreductases. So each class contain more than 5 subclasses, and that depending net on what particular receptor they are working, or what is the particular molecule they are working as a catalyst, right? Next is the if you just look at this, so next is the transferases, right? So here you can see A, B, and this is one molecule, and A and B is, you can assume that this is the side of that molecule, functional group, you can say. So A, B, and C. And after that one, so after that, A has transferred from B to the C side, right? So this kind of enzymes are the transferases one. So here you can see the different subclasses, and these are transferase phosphate or the phosphorylase. So these are depending on it that what particular reaction they are catalyzing. Now the hydrolysis is basically, this is one the hydrolysis of that substrate, and it means there is the water involvement in that reaction. So AAB, so water molecule dissociate into the H positive and OH negative. So A is attached with the proton and the B is OH. So this is just a general kind of reaction. So you can just see that there is involvement of water molecule, and the product has formed after the hydrolysis of that substrate one. Next is the liases. So liases is basically where there are the new bond formation or the breakage. So usually if there is the synthesis, so it means there is a link of two molecules, and there is, if they are the decarboxylases, so it means there is the functional group carbon dioxide which has removed from that one. And if we will reverse the direction, so that would be the carboxylases, means there is the addition of carbon dioxide. So there is a different bond formation, and in the previous slide we have mentioned that it involved ammonia, carbon dioxide, and different molecules which are joining or either forming. Now the next fifth one is isomerases. So this H3O is just to give an idea that we have formed a different isomer of that molecule. So again, this is A, which has converted into an A product, but with the different isomeric form of it. So there are the subclasses, racemases, we can interconvert L and D conformations of the product, and there are the mutases, transfer group between atoms within a molecule. Now the last one is basically the ligases, which involve ATP molecule. So this is just like the hydrolases one, but hydrolases involve the water molecule and ligases involve the ATP for conversion of the um, substrate into the product one. So obviously, whenever there is ATP, ATP is adenosine triphosphate, where there are the three phosphate groups, and when there is involvement of ATP, and this is conducting a reaction, it means it is either giving the phosphate group or it is taking the phosphate group. But usually, when the ATP break up, so it generate the certain amount of energy, and that energy is required for conducting that reaction along with enzyme. So that's why AB plus ATP, and you can see the AB is a product. Now there is the inorganic phosphate group which has detached from the ATP, and after leaving one or giving one phosphate group which was a triphosphate, now this is adenosine diphosphate. So its subclass is carbon dioxide, uh, carboxylases, which use carbon dioxide as a substrate, synthesases, link two molecules by an ATP dependent reaction. So you may confuse with synthesases synthesis and synthetases. So basically, synthesis is the subclass of the lysis where they are the formation of two new molecules, and the synthetase is basically the subclass where they are the new molecules formation but with the involvement of the ATP. So these are the different classes. So in major, you have to look into the reaction types, so that could be the different questions you may ask, that looking at the particular reaction type, that what is a product is formed, so what is the class of enzymes which is conducting that reaction. So you will look into very broadly. You have to think broader, like what kind of reaction it is, and either there is an involvement of water, either there is the isomerization, either there is a transfer of a group, either there is involvement of ATP, and then you will suggest the class of that enzyme. So I hope you get an idea, and this is the basic lecture about enzyme, where we have defined it, where we see how they work and how it acts on the substrate one, and what are the different classes of enzyme. So one more thing, and I just wanted to mention that I hope that you know what the active site of it, because the enzymes are working through their active sites. So active sites is basically the head point, you can say, or their more potential site, or their reactive site from which it can conduct the enzyme activity. So obviously they are the different amino acids, and the substrate has to bind with that one. So that could be the induced fit model. Then firstly, that will modify itself and fit into the active site. So enzyme is not participating as a whole, as a whole molecule. There are the different active sites which are participating for that active site. So an enzyme could have more than one active sites. So we'll talk about later more in details regarding different factors which affect the enzymes and regulation of enzymes. So just wait for the more lecture videos. Take care. Bye.